Hey everyone, I'm Inam. I'm thrilled to welcome you all to today's video lecture on analysis and design of retaining wall. In this series of video lecture, we will be discussing about the retaining wall subject reinforced concrete design 2, in which we will focus on what is retaining wall, different types of retaining wall, function of retaining wall, and different failure modes of retaining wall. In the same lecture, we will touching the design part of the retaining wall, in which we will study about the geometry of the retaining wall, the SI code, and the load factor, etc. So this will be mainly the introductory part about the retaining wall. So the first question arises that what is retaining wall? A retaining wall is a structure which resists or retain the backfill soil or the pressure caused by the backfill. It will resist these pressures. So the main function of the retaining wall is this. Since we know that the function of the retaining wall is to retain the backfill soil or resist the lateral pressures caused by the backfill. So what is the backfill? Backfill is the part of soil or any material which is resisted by the retaining wall mainly. So there are different types of retaining wall: L-shaped retaining wall, T-shaped retaining wall, and T-shaped with shear key retaining wall. If the wall does not provide sufficient resistance against sliding, so then we will introduce a key which is known by shear key beneath the stem, beneath the foundation. So we will provide a projection of a slab beneath the stem or beneath the foundation to resist more friction against sliding. There are different types of retaining wall: gravity retaining wall, semi-gravity retaining wall, cantilever retaining wall, buttress or counterfort retaining wall. The function of the retaining wall is same, is to resist the backfill soil or resist the pressure caused by the backfill. So the main function is this, and the basis of this function, the retaining wall are divided into different types. The number one is gravity retaining wall, semi-gravity retaining wall, cantilever retaining wall, and buttress retaining wall. Gravity retaining wall are those retaining wall which resist the backfill or lateral earth pressure caused by the backfill by its sulfate. With the help of its sulfate, it will resist the backfill. So from this we know that it may have large size, different section of large sizes, so it may be non-economical, and it is non-economical due to its huge geometry, more size, so it will resist the backfill. And the second type of the retaining wall is the semi-gravity retaining wall, which is the modification of gravity retaining wall, in which we will introduce a minimum amount of reinforcement to reduce its size and resist the backfill or lateral pressures. So the here it's the semi-gravity retaining wall. In one side, the backfill, normally the soil is retained by the wall of the stem, and here is the other parts. So this is the typical diagram of the semi-gravity retaining wall. It's also not economical because it's the modification of gravity retaining wall, in which it is economical as compared to the gravity retaining wall, but as compared to other retaining wall, it is not economical. Remember, this is the main point. This is a modification of the gravity retaining wall, in which minimum amount of reinforcement may be installed in this wall to reduce the sizes. The size of the gravity retaining wall is more as compared to the semi-gravity retaining wall. The third type of the retaining wall is the cantilever retaining wall, in which the one side is fixed and the other sides are cantilevered. So from this we can know that these are the completely reinforced retaining wall, in which a reinforcement may only be used. So these consist of L-shape, T-shape, T-shape with shear key. So there are different types of cantilever retaining wall. It consists of thin stem. The vertical part of the retaining wall is called stem, Here you can see that this is the stem, and the base also called heel, and toe, this is also called the foundation of the retaining wall. So these type of the retaining wall are widely used because of the reduced sections, reduced sizes as compared to the semi-gravity and gravity retaining wall, and it is economical as compared to the previous one retaining wall. So there are different typical diagram of the retaining wall. It has heel part, toe part, base slab, toe slab, backfill, and stem, which is also called arm of the retaining wall. Another modification of cantilever retaining wall is the buttressed or counterfort retaining wall, in which in each side or one of the side we will provide the inclined braces, inclined support to support the stem or arm of the retaining wall. So on the basis on the placement of the location of the counterfort or basis or the inclined support, the retaining wall are divided into two types. The one is buttressed retaining wall and another is counterfort retaining wall. If the inclined support or the inclined braces or the counterfort are provided at the backfill side, then the type of the retaining wall may said to be counterfort retaining wall, in which the braces are provided at the backfill side. You can see that this is the backfill side. Here the soil is retained by the retaining wall. The support or the counterfort are provided at the backfill side. So this type of the retaining cantilever retaining wall may be called counterfort retaining wall. If these inclined braces or the buttresses is provided at the opposite of the backfill, then these cantilevers wall said to be buttress cantilever wall. So as you from the figure you can see that this is the backfill portion. This is the backfill portion, and here the buttresses are provided. So the only difference is the location of the counterfort or buttresses. From this we will name the retaining wall. So the main purposes of all types of the retaining wall is to retain the backfill or resist the lateral pressures. There are different components of the retaining wall that will be used in design. We will design each component, its thicknesses, the reinforcement, and we will check the stability. Different three checks: stability checks, overturning checks, the beneath soil pressure checks. So there are different components of the retaining wall. The major one is the stem, the vertical part of the retaining wall, which retain the backfill, which is called arm or stem of the retaining wall. The second one is the foundation of the retaining wall, which consists of toe slab and heel slab. Here you can see that heel and toe. What is the difference between toe and heel? Heel is the part of the retaining wall at the backfill side, means the foundation of the retaining wall at the heel side, the base of the retaining wall at the backfill side, and toe is the foundation of the retaining wall at the opposite of the backfill side, at the face side. The slab or the foundation or the base of the retaining wall is called toe. This is the only difference between toe and heel. There are a lot of weight come on heel slab and the less on toe slab, and the arm is the vertical portion, vertical arm of the retaining wall, which retain the soil foundation, which on which the arm is seated, so which transfer the loading on the beneath foundation. Now we will coming towards the design part, in which the first step is to determine the geometry. So as per the ASCI code, the geometry of the cantilever retaining wall be in this. So from the top of upper portion of the stem will be from 8 inches to 12 inches, should be in this range, the top of the stem, and the bottom of the stem should be in this range, h by 15 to h by 10, where h is the total depth of the arm plus base slab. H is this length, so the bottom of the retaining arm stem will be h by 15 to h by 10. In this range we will be taking this value from this range, and the base of the retaining wall should be in this range 0.4 times of h to the 0.65 times of h, where h is the thickness, means the depth of the retaining wall from upper portion of the stem to the lower portion of the foundation or base slab, and the thickness of the toe slab or heel slab should be in this range h by 15 to h by 10, and the length of the toe should be 1/3 of the base length. So this is the geometry of the cantilever retaining wall as per the ACI code. So we will covering this topic in detail while we will solving a numerical. So now we will discussing different types of failure in retaining wall. There are mainly three types of failure will occur in retaining wall. The first one may be the parts of the retaining wall may be fail. The part of the retaining wall are stem, toe, heel. Maybe these fail and not provide enough resistance to bear the or support the backfill. So these structure may be fail. This is a structure failure. And another failure is the stability failure, means the bodily displaced of the retaining wall occur. The overturning may occur, the sliding of the retaining wall may occur. So I will show the figure of the sliding or turning in next slide. And the beneath soil may fail if the soil does not provide sufficient bearing capacity, so it may be settled on and the whole retaining wall may be fail. So these three major failure will occur in retaining wall. While designing a retaining wall, we will counter each of these failure. If anyone is allowed to fail, so the whole function of the retaining wall will be fail. So in design we should consider these and counter these failure. So the failure diagram will be in this manner, that the stem will buckle, stem of the retaining wall buckle, the overturning may occur, the wall may overturn, the sliding may occur, the whole body of the retaining wall may display from the initial position. The settlement beneath the foundation may occur if the bearing capacity is lower than the applied load. Then the settlement may occur and the retaining wall may be fail. Since we are designing a retaining wall or any structure as per the amplified load and reduced strength, so we will amplify load by introducing load factor. So the load factor for the retaining wall may be these different types of load factor on different location. For the pressure of the soil or the backfill, we will use the load factor 1.6, and for the weight of toe slab the load factor will be less 0.9. For the weight of heel slab 1.2. For low weight of the surcharge we will use the load factor 1.6. So the surcharge is taken as a live load. This is the very important slide of a retaining wall. What is the resultant lateral pressure and what will be the location of these lateral pressure? So if the condition is this is the scenario, if there is no inclined backfill and no surcharge, then the lateral pressure will be half into kh into wh square. So w is the load, h is the depth of the backfill or the height of the backfill, and k is the lateral earth coefficient for active case. So this will be the first formula for this scenario. And for the second condition, if the backfill soil is inclined, then the formula may be changed. The lateral earth pressure will be 1 by 2 times of Ka into W into H square, where K is the lateral earth coefficient, W is the load, factored load, H is the depth of the backfill soil, and Kb can be calculated by K cos theta, and theta or the resistance between the soil and the retaining wall may be taken as sigma, or the angle of internal friction. This will be the formula, and the y will be the y by h by 3. This will be the location of the retaining wall, the resultant force. For this condition, the only K will be changed. And for the last condition, if the surcharge load is applied, then what will be the formula? The formula may be little longer as compared to the both two other types. So if the surcharge is applied, then the formula for lateral earth pressure will be K times K 1 by 2 times of K into W into H plus 2H dash, where H dash is the thickness of the surcharge and H is the total thickness, W is the load, factored load, K is the lateral earth coefficient, and the resultant location of the resultant force will be this: H square plus 3H, H dash divided by 3 into H plus 2H. So the formula and the location for the resultant force will be changed as per the scenario at the site. So this is the very important slide of the lateral earth pressure and the location of the resultant force in retaining wall. So these all will be used in the analysis part of the question, numerical question. For moments, these all, and for moments and the stability checks, these different formula will be used. Now the last is different weights are used in stability and in design. So the weight of the parts of the retaining wall, the surcharge load, weight of the surcharge load after multiplying with the lateral earth coefficient, the effective earth pressure, the active earth pressure, and what is the soil effect, it will also be considering in stability check. So these all will be covered in detail while solving a numerical. So this is the introductory part of the retaining wall, in which we had learned about retaining wall, its function, different types of retaining wall, failure modes. So thanks to everyone. Allah Hafiz.